Hello student, I am Dr.A.K. Today I will continue from the last class and I am going to discuss shapes of atomic orbitals. Shapes of atomic orbitals. This is also very important from the concept point of view. The orbital's wave function. The orbital wave function or psi for an electron in an atom has no physical meaning. It is simply a mathematical function of the coordinates of the electron. However, for different orbitals, the plots of corresponding wave function versus function of r, that is the distance from the nucleus, are different. I will enclose one sheet of this diagram. You can see in that. Now this for 1s and for 1s and for 2s, I will send the diagram. According to German physicist Max Born, the square of the wave function, that is the psi square at a point, gives the probability density of the electron at that point. The variation of psi square as a function of r for 1s and 2s orbital is given in diagram. We have sent the figure that you can see. Here again you may note that the curves for 1s and 2s orbitals are different. There is a difference in curve for 1s and 2s. It may be also noted that for 1s orbital, the probability density is maximum at the nucleus and it decreases sharply as we move away from it. On the other hand, for 2s orbital, the probability density first decreases sharply to 0 and again starts increasing. After reaching a small maxima, it decreases again and approaches 0 as the value of r increases further. The region where this probability density function reduces to 0 is called nodal surface or simply nodes. In general, it has been found that as orbital ns orbital, n means small n, number of orbit, the ns orbital has n-1 nodes. This question is asked. Again I am telling it has been found that n means number of orbit, ns orbital has n-1 nodes. That is, number of nodes increases with increase of principal quantum number n. This is asked many times. Question has been asked. In other words, number of nodes particularly for 2s orbital is 1, 2 for 3s and so on, means one less. Again I am telling you that number of nodes for 2s orbital is 1, and 2 for 3s, and so on. This probability density varies can be visualized in terms of charge cloud diagram. That also I will attach there in video. You can see this probability density variation can be visualized in terms of charge cloud diagram. In this diagram, the density of the dots in a region represents electron probability density in that region, where electron can be found, that you can see. Now, second things I want to tell you now today, that is the boundary surface diagram of constant probability. Actually, boundary surface diagram I am going to discuss. In that you should understand here, boundary surface diagram of a constant probability density for different orbitals give it fairly good representation of the shapes of the orbitals. In this representation, a boundary surface or contour, you can tell contour surface diagram, both are same. A boundary surface or contour surface diagram in a space for an orbital on which the value of probability density, that is the psi square, is constant. Again, I am telling you this. This is an important point. In this representation, a boundary surface or contour surface is drawn in a space for an orbital on which the value of probability density, that is a psi square, is constant. In principle, many such boundary surface may be possible. Here you should know, if probability density psi square is constant on a given surface, then psi is also constant over the surface. This is an important point. If probability density psi square is constant on a given surface, psi is also constant over the surface. The boundary surface for a psi square and psi are identical. Okay, this is an important point I have told you. Now I am going ahead. In principle, many such boundary surfaces may be possible. However, for a given orbital, only that boundary surface diagram of constant probability density is taken to be a good representation of the shape of the orbital, which encloses a region or volume in which the probability of finding the electron is very high, say 90%. The boundary surface diagram for 1s and 2s orbitals are given. I will send it. I have provided. 1s and 2s orbitals are given. One may ask question here, why do not draw a boundary surface diagram? Here, this thing, 90% I told you that probability can be found. The boundary surface diagram already told you will provide. Now question arises, one may ask a question, why do we not draw a boundary surface diagram which bounds a region in which the probability of finding the electron is 100%? Why only 90%? This the question may be asked. Then answer of this question I am giving. Why only 90%? Why not 100%? The answer to this question is that the probability density psi square has always some value, howsoever small it may be, at any finite distance from the nucleus. It has some value. It is therefore not possible to draw a boundary surface diagram of a rigid size in which the probability of finding the electron is 100%. In rigid side, probability of finding electron is 100%. Boundary surface diagram for a s orbital is actually a sphere centered on the nucleus. In two dimensions, this sphere looks like a circle. It encloses a region in which probability of finding the electron is about 90%. This I have discussed. 2 points I have discussed today: shapes of atomic orbitals and boundary surface diagram. Now this I have finished full this chapter, a structure of atom. I have finished complete 100%. Now before closing today's lecture, I want to discuss 1-2 numericals based on these things. Yesterday I have discussed about the quantum number. Then sometimes some numericals is asked, means calculation in examination they are asking in competitive examination, that I will discuss, because that is very very important in all examination, medical, engineering, or in general UPSC also they are asking. Even for CSIR also sometimes they are asking. Then it is easy, it is full of concept. What yesterday I discussed, this is based on that, and it is based on the relation of NLM, means principal quantum number, azimuthal quantum number, and magnetic quantum number. It is based on these three relation. Always you have to keep these three relation, then quickly you can solve the numericals. Now I am just example. I will give a question I am reading, then you can solve it very easily. I think so. What is the total number of orbitals associated with the principal quantum number n is equal to 3? See how easy question is there. Again I am reading the question. What is the total number of orbitals associated with the principal quantum number n is equal to 3? Means n value is given 3. Then what is the total number of orbitals? I have already told you there is a direct formula. If number of n value you are knowing, number of orbit you are knowing, then how many orbitals will be there? I have given one formula. Just remember, n square, a small n square. Then now n is 3. Then how many orbitals? Then 3 square. 3 power 2, that is 3 into 3, 9. 9, just in one line formula you are knowing, directly quickly you can tell the, you can say number of orbitals, 9. And this also you can, after analysis also you can tell n is equal to 3. N is equal to 3. Then you can also calculate like that. Long process I am telling you, short process, that direct formula 3 power to 9 calculated. But long process n is equal to 3. Then in 0 that is the S, n is equal to 3 means you are talking about the third orbit. In that 0 will be there, 0 S, P, D. S will be there, P will be there, D will be there. Then S means 1 orbital, P means 3 orbital, D means 5 orbital. Add all three. S means 1 orbital, P means 3 orbital, then 1 plus 3 plus 5. 5 total 9. Then long way like this also you can calculate. Orbit number 3 means 3 sub-orbit will be there. 3 sub-orbit means S, P, D. Then in S only 1 orbital, in P 3 orbitals, and in D 5 orbitals. Then 1 plus 3 plus 5, total 9 orbitals. Now second question I am reading, that is again it is if you have understood really, then it will be very easy and very good in solving also. You will feel good, full of concept. Now I am reading a question. Using SPDF notations, describe the orbitals with the following quantum numbers. Quantum number they have given. Then according to using SPDF notation, describe the orbitals. They are asking only about the orbitals with the following quantum numbers. This question is very, very important question. This type of question they are asking. Then means quantum number they have given, and now you have to find out the orbitals. Then now they have given first question, they have given n is equal to 2, L is equal to 1. Question, the first question is that n is equal to 2, L is equal to 1. Then you tell the orbitals. Describe the orbitals. Then see, actually there are 4 questions are there. First I am telling you n is equal to 2, L is equal to 1. Then you tell, describe the orbitals, which orbitals they belong. Then n is equal to 2 and L is equal to 1. Then n is equal to 2 means, yesterday I have discussed, n is equal to 2 means, and L is equal to 1. How you keep in mind, 0 represent S, L represent 0, 0 represent S, 1 represent P, and 2 represent D, and 3 represent F. This you keep in mind before solving the numericals. Then here n is equal to 2, L is equal to 1. Then n is equal to 2 means you have to write first 2. You are talking about the orbit number 2. And L means 1. L means 1, and 1 means P. Correct? L is equal to, they have given 1. Then 1 means P. Then orbital is 2P. Like that way, second question is there. N is equal to 4, L is equal to 0. Then n is equal to 4 means 4 you have to write, and 0 means S. Hence 4S. That is the 4S orbital. Now next question is there, question 3, that is n is equal to 5, L is equal to 3. Then 3 means, again you keep in mind, 3 means, n L is equal to 3 means 0 SPD. You are talking about D. If L is equal to 3, it means D. Correct? If L is equal to 3, the third is what? SPD. SPDF, that then SPD. Then now n is equal to 5, L is equal to 3 means 5. No, this 3 is there, L is equal to 3. Then 3 means 0 0, 1, 2, 3 means S, P, D, F. Fourth is coming F. S, P, D, F means 0, 1, 2, 3. 3. Then here question is n is equal to 5, L is equal to 3. Then n is equal to 5 means 5 and 3 means F. S 1, 2, 1, 0, 1, 0, 1, 2, 3. Fourth are there, na? Then S, P, D, F. Then you are talking about orbital is 5F. Orbital is 5F. N is equal to 5, L is equal to 3 means 5F. Like that way, last question is that N is equal to 3, L is equal to 2. Then 3 means again 3 you have to write, and 2 means again 0, 1, 2. 0, 1, 2 means S, P, D. Then you are talking about the 3D. Then orbital is, given orbital is 3D. If N is equal to 3, L is equal to 2, then orbital is 3D. Then I have discussed this also, numericals. This type of numericals only they are asking in almost all examination. Then doing practice is needed for other numericals also. Then you will be able to solve. Really this type of concept is same. Then now this big chapter I have finished. 2 chapters I finished. First chapter I finished, basic concept 100% I finished. And second chapter, atomic structure or structure of atom, you can tell that 100% I have finished. Today now I am stopping only here. Next class I will start periodic table. Okay, thank you.